Hello everybody, today I am back with another video, and today I'm going to be recording for a problem that I actually came across on Quora. It seemed pretty hard at first. It's actually a limits and continuity problem, which if you don't know is from Unit 1 of AP Calculus AB. If you're in BC, this is also relevant as well, since all the material in AB is also in BC. But anyway, let's get right into it. And so I think this was part of an FRQ. It says part C right here. And so we are going to see what it's all about. So we have, let k of x is equal to f of x plus g of x. And we got a graph of f right here and a graph of g. Oh goodness. This ink is quite large. Okay. Is equal to f of x plus g of x. Consider x is equal to -1, x is equal to 2, and x is equal to 4. So at each of these points we can notice some things. So let's go to graph of f. If you can see my cursor, x is equal to -1 is right here, x is equal to 2, and x is equal to 4. X is equal to -1, x is equal to 2, and x is equal to 4. So at which one of these does k have a jump discontinuity? Justify your answer for the jump discontinuity using the correct limit notation. So limit notation is pretty much like this. For those of you who don't know, it would be kind of strange if you didn't know what the limit notation was. I'm assuming you've done limits and continuity for some time. So let's say it was 5, for example. We're going to be using -1, 2, and 4, but this is the kind of limit notation. And by the way, plus means right-hand limit, minus, I might also put a minus sign here. Let me make this a bit more clear. Minus sign, that would be a left-hand limit. So let me erase that. And a jump discontinuity, you can find that out when the right-hand limit and the left-hand limit for a single value of x is not the same. So if I had limit of x approaching 4 from the left side, limit as x approaches 4 from the right, if those were unequal, then I would have a jump discontinuity. So let's start with x is equal to -1. So let's go to x is equal to -1, which is, I saw my eraser. X is equal to -1. I'll use a red instead. So x is equal to -1 is right about there. And on the graph of g, it is right there. So at x is equal to -1, what we do, we can notice that both f and g are piecewise functions. So f, we need to find out the equations of these lines. And there are many ways to do this, but this is a pretty good way of doing it, especially with piecewise functions. So we need to find the linear equations. These happen to be linear equations, so that's pretty convenient for us. So what is the linear equation as we see it on the left? So right here, you can solve it in a multitude of ways, and one is a bit more visual, another one is more algebraic. You can use the slope formula to find an equation for the line, use point slope form, for example. But what I like to do is to do it a bit more visually. So if you notice that the sizes of each of these are 1, so it goes up by 1 every time. We have x equals 0, x equals 1, 2, 3, 4. So it goes up by 1 every time. Same deal on the y-axis. So we can determine that as x decreases, y increases. Also, when x increases, y decreases. This means we have a negative slope. So let's start graphing, writing the equation actually. So we know that it's a negative, and we have x. And if you guys remember, y equals mx plus b, so we're going to have plus b here. And we don't know what m and b are yet, but we can take a guess since we see that as x increases by 1, y decreases. So we can just assume that it's going to be 1x. And by the way, when I finish this, you guys can check it by solving it with the slope formula, the one that you've probably known for a while now. You can try solving it with that, and you will probably come up with the same result as I do. And you'll notice that, let's say if I were to keep on drawing this line, let's say if this line were to just keep on going individually, it would eventually hit the y-axis right here, and it would be -1 as b. So y equals mx plus b, m is going to be -1, and b is going to be -1 as well. So on the left side limit, on the left hand limit for the graph of f of x, keep in mind we need k of x. We are going to be using the function -x minus 1. Now how would this look if we were to actually solve it for k? So we're going to do x as it approaches -1, and keep in mind we've only been dealing with the left hand limit for now. I'll get to the right hand limit, and then we're going to deal with it in a pretty similar way. But for now, let's just do, this is the symbol for the right hand. The left hand symbol is this. So limit as x approaches -1. And so we have this function right here, and keep in mind you add it to g of x. If you remember here, k of x is equal to f of x plus g of x. You need to notice this relationship here. On a different problem, it could be f of x times g of x divided by whatever it is. You need to be careful of that. For now, they've given it to us pretty simple, which is good. So as x approaches -1 on the graph of g, what is it? We can see it's just a straight line, really. It's at y equals -1. So that means if we were to we would imagine that if this were extended, if we were to extend this part of the graph, we would, sorry for that, but it would keep on going in either direction. So let's erase that. So basically that would mean that f of x plus g of x, as it approaches -1 from that side, we get f of x. So we found this for f of x in this piece of the piecewise function, minus x minus 1, and we have g of x, which is x equals -1. So if you then we can combine this. So remember, this is f of x, and then we're adding that to g of x, because that's what k of x is as defined in the problem. So g of x. So g of x, f of x, and g of x, and keep in mind we're adding them, so that means it is k of x in fact. And so if we solve for this, we can just directly substitute it in, as you would first do with limits. And you would find that you would get an answer of -1. You would get -1 for the left-hand limit. So if we were to take the limit of k of x, you can solve it in there. You can go a few seconds back and then check that, hey, was it really -1? And you can actually, and then I'm going to write it down right here, k of x, the limit as x approaches -1 on the left hand side of k of x is equal to -1. Now let's solve it for the right hand side, and let's see what we get. So on the right hand side, we are going to, let's erase some of this a little. We see another linear function, and we see another straight function. So this is going to be pretty similar to what we did solving for the left-hand limit, but except with some different values. Now you can try to find out this. It's going to be pretty simple. This is actually just y is equal to -x for the left hand for the f of x. So yeah, this is the right hand side of f of x, right hand. So this time we're doing right hand. So y is equal to -x. You could put +0 because that's where the intersect is, but it's really the same thing. Y is equal to -x, and this one is y is equal to 1. And you could replace it with f of x and g of x. That would also work. I would actually recommend you do that because then it's easier for you to see how it really works. And this would be f of x, the one where my cursor is right now. This would be g of x, where my cursor is right now. And so you'd add this minus x plus 1. And we would do the same limit, except we're going to have it with the plus sign representing that it's on the right side, sorry. So x as it approaches minus 1, we're going to have plus, oh goodness, storage. So that is going to give us minus 1 times minus 1, and that is going to be minus 2 plus 1. Sorry, no, 1 plus 1. That's just 2. Sorry. And we have 2 and minus 1. That means there's a jump discontinuity at x is equal to minus 1. And this will do it fine. You can check with the other ones, but I'm running out of storage right now and I can't record the others. So sorry about that. Thank you guys so much for watching again. Please do subscribe and like if you did enjoy the video or if you found it helpful. Thank you guys so much for watching once again.